Today, part D, SQL constraints. We talked about a little bit before on the constraints. The constraints we discussed before, that's mainly the DBMS applied constraints automatically, built-in. We call the built-in constraints. We do not need to do anything there. But today, we talk about user-defined constraints. Yeah. Because we feel the built-in constraints still not enough. So we need to define our own constraints. Yeah. All right. First, constraint name. We learned a little bit about name before. I mentioned that. Yeah, we saw one example, and I said, if we need to modify it later, we need to give it a name. Otherwise, if you do not provide a name, still you can define a constraint. But later, it won't be convenient to do anything on that constraint. Yeah. Here, we just repeat the same thing. So this one, a constraint may be given a constraint name following the keyword constraint. Yeah. Although it's optional, but most of the time, we'd better provide a name for our user-defined constraint. All right. Properties of a constraint name. Yeah. All right. Giving name to constraints is optional. All right, yeah. So you have, sometimes you may have some reason without choosing a name, but you need to know if later you want to do something on this constraint, if you are prepared to do that part. Yeah. The names of all constraints with a particular schema must be unique. Yeah, yeah, that's simple requirement. By logic, it's natural. Yeah, with a particular schema. So here we know one schema corresponds to one database. So it is within one database, then your constraint names must be unique. Yeah. But for different databases, then if you use the same name, so no problem, no conflict, yeah, because they are independent databases. Yeah. All right. A constraint name is used to identify a particular constraint in case the constraint must be dropped later and replaced with another constraint. Yeah. If you want to do some change on it. Yeah. But I also mentioned the last time, if we do not give it a name, but later we want to drop it. We want to drop it. We want to first, we want to drop it. We want to drop it. Yeah, it is possible. All right. There is no name, but not convenient to drop it. Remember, not convenient to drop it because there is no name. So that means if you want to write a SQL statement to drop it, it's hard. No reference, right? No reference. Yeah. But you can go to the DBMS. Yeah, MySQL, you have a list of constraints, right? In your GUI, that manage. Yeah, I need to select here. Noah, Kazawi. I will check. Yeah. All right. So in your GUI, that interface there, you have a chance to select one particular constraint, even without name, you can still, it is listed there, right? So you can check the check box and then drop it. So you still, you have some way to drop it, all right? But you must have that DBMS control for you. Otherwise, it will be hard. Yeah. All right, so this part should be easy. All right. Then let's look at how to define a constraint with check clause. Check. Yeah. You need to check some condition. Check clause. So you define with a name, check. You apply a condition after that check keyword. Yeah. Let's look at a few cases here. Create a user-defined constraints. Yeah. There are these three types we can define. First, on an attribute, we want to apply certain condition on an attribute, a field, or a column. Yeah. Yeah. After an attribute, yeah, we put that check clause. Yeah. So let's look at this example. Yeah. Look at this one. Yeah. From now on, all these examples based on company database. Yeah. Yeah. That one I haven't uploaded, but when I go home today, I will upload that database script. All right. Yeah. Okay. Yeah. So that I talk about that company. .SQL. All right. Yeah. Company database. Yeah. All right. Yeah. Before I give you that script, today I just talk about those things related to constraints. Yeah. Yeah. All right. So look at this example, D number, department number, yeah, department number, integer type, not null, all right, then check. After that, we want to apply what is a valid department number, right? We want to specify the range for a valid department number. So look at this check clause, check, yeah. Parenthesis condition. So it's a Boolean expression, true or false, right? Boolean expression. All right. D number greater than 0 and D number less than 20. So we provide a valid range for department number. Yeah. So with this constraint, yeah, do we have a name? We don't have a name for it, right? Yeah. So there is. So here we apply this constraint. Yeah. So there is name for it. No name for it. Yeah. You will see after you define this constraint, later when a user enter any record containing department number, this constraint, the DBMS will apply this constraint on that automatically. Okay, so you don't worry. So it's there. The DBMS will complain if the department number is out of this range. Yeah, so that's simple. Okay, yeah, that's the first case. Yeah. Second case on a domain. Yeah, domain. I haven't talked about this domain concept. Yeah, but it's pretty straightforward. Yeah, the range for certain number. Yeah, that's a domain. You specify a domain. So for some number, yeah, not necessarily numbers, for data, for some data type, then you specify certain range for that data type. Yeah, that's the domain. Yeah, here we see it from this example. Yeah, after a domain name, yeah, you need to provide a domain name. Yeah, so later you can manipulate using that name. Yeah. Look at this example. Create domain keyword, then domain name d_num. Yeah. Here, for example, you want to define a range for some special purpose for certain data type, yeah, with this reference name d_num as then data type integer, as integer. Then check clause to put a range for this domain. So the check clause, parenthesis, d_num greater than 0 and d_num less than 21. That's the range. All right. After you define this domain with this name, and then later you can apply this domain to other fields when you need to declare for certain value range. Think about that. So you have the convenience because you already defined that domain. Later you can apply the domain on a particular field directly. So you do not need to repeat the same range information anymore. Yeah, you know, so that's the way we can use this domain. All right. So that's the case number 2. Case number 3 on the table. Now we apply or we define a special constraint that is applied on one table. Okay, yeah. So after a table definition, we make tuple-based constraints. The constraint is applied on the whole tuple. Whole tuple. All right. All the fields, all the values for those fields in that tuple, we apply some condition with, business rules, for certain business rules. Yeah. All right. Look at this example. Yeah. All right. Create table department. So then your table definition. So we skip that part. All right. Then at the end of your table definition, you want to apply some special condition. Yeah. So check clause. Yeah. Here we do not have a name, constraint name. Yeah. Here we just, check. Yeah. Check. Then the condition. We apply on tuples. For each tuple, we apply this condition check. All right. Yeah. The department create date should be less than or equal to the manager start date. Yeah, that logic is quite natural, right? You need to create that department first. Then the manager start date must be after that creation time, right? Yeah, that's the logic. Yeah, but if you do not define this constraint, nobody will check it for you, right? So you need to ask programmers, or some responsible people who need to manually check this condition. Yeah. So that's not efficient. So here you can see many relatively simple rules. We can use constraint like this. So we can ask DBMS to enforce those business conditions, requirements. But you can see, usually the constraint we define here as user-defined constraints. Yeah, 3 is here. Noah and the 3 came in late. Yeah. I hope at the end I can check their names. Yeah. All right. I said for relatively simple conditions, we can do it in this way. Yeah. All the conditions, less than, greater than, those relatively simple conditions. We can use constraint, user-defined constraints to enforce, to make DBMS to enforce these conditions. But on the other hand, for complex conditions, you cannot do it in this way. Complex. For complex constraints, then we have to store the procedures. We write a function. Basically, we write, SQL functions. Use complex logic to enforce constraints. Yeah. So that part. Yeah. So you don't worry. Yeah, because you may feel the constraints we define in this way still not good enough. Yeah, you may feel in that way. Still not, we cannot do all types of constraints here. That's true. That's true. Yeah. But we have our last tool we can apply, store the procedure. All right. Okay. Yeah. Next topic, D.2, referential integrity constraint. This type of constraint related to foreign keys. So in this part, we will talk about foreign keys. So it's called a referential integrity constraint. Okay. All right, so let's take a look. Yeah. All right. Referential. We need to look at two tables. One references the other, that kind of structure. Yeah. The goal, maintain consistency among tuples in two relations. Yeah. Yeah. I will use some diagrams to explain the relationship. All right. Yeah. What? Yeah. Between two relations. In order to see the relationship a little easier, here I need to introduce some notations. Yeah. All right. Referencing relation R1, relation 1, yeah, because this one needs to reference certain field in another relation. Yeah. So we call it referencing relation. The first one, R1. The second one, the relation to be referenced, R2. Yeah. We call the referenced relation R2, capital R. Yeah. So that's the relation notations. Then tuple notations. Yeah. When we look at this kind of constraint, we need to use tuples for our discussion. Yeah. All right. So for tuple notations, T1, a tuple in R1. Okay. A typical tuple in R1. Yeah. T2, a tuple in R2. Yeah. All right. So then we can draw a diagram. Yeah. Using this example. Yeah. Here, this diagram still based on our company database. Yeah. In our company database, we have an employee table, R1. R1 is our employee table. Yeah. R2, department table. Yeah. They have some correlation. So we want to connect these two tables through some special key field. Key field, the key field. Last time we defined a key field. Yeah. All right. So let's look at the specific relationship. Tuple 1, T1 in R1, like this. Yeah. All right. Tuple 2 in T2, a department tuple. Yeah. T1, an employee tuple. All right. Then In employee tuple, there is one field. Yeah, so we select this field. All right. That field, there is a name called a DNO, D-N-O, DNO, department number, but we try to call a different name, DNO, okay, yeah, because the same thing in a different table, we will use different name to call it. All right, so in the R2, still department number, we use D number to call it. In this way, yeah, the main reason, later you will see, we want to avoid confusion. All right, we want to avoid confusion. Otherwise, if you call the same name, for example, D number, the same name, then when you talk about D number, you may not know which table you are talking about, right? Yeah, because this name comes from two different tables. So which table we are talking about? So you get confused. Here we intentionally use two different names, DNO, D number. Then when you see different names, you know they come from different tables. Yeah. So it will be a little easier for us when we work on our queries. Yeah. All right. Relationship. Yeah. They refer to the same object. DNO, D number, same object, department number. Yeah. And a D number in R2, we use it as the primary key. Department, we use department number as the primary key. Okay. All right. Then in table 1, R1, DNO, yeah. So that here, that point connects to T2, D number, that one directly. All right, so you know, consistency here. This arrow point to that means consistency. We have to maintain, this is called the referential integrity, the consistency. Yeah. D number you find in R1 for this particular T1 tuple, it must refer to some primary key value somewhere in R2 table. Yeah. All right. Yeah. So that kind of relationship. All right. Yeah. And we call this denote that field, it's a foreign key. Now you understand this concept, foreign key. Now, this concept, we need to spend quite some time to understand. Yeah, foreign key. Yeah. So you may hear foreign keys, many different situations. Yeah. So here we're learning foreign key concept. All right. And the point, so here in one table, you use the values, but it refers to the primary key in another table, primary key in another table. That's the foreign key. All right. Yep. Okay. Yeah. All right. Another case. So here, the foreign key value, denote, that value could be null, right? Yeah. When we do the referencing, that value could be null. Yeah. We know the meaning of null here, unknown. Yeah. Although we know we need to reference one of the departments in that department table. But at this point, we do not know this employee belongs to which department, right? That information is unknown. That's possible. Yeah. So you may have the null value for that denote. field. Yeah, but for the primary, you cannot have value. We know the primary key is not allowed to have the null value. All right, yeah. Okay. Concrete example. Yeah. Here, I show you two complete definition of two tables, then foreign key relation. Yeah. All right. Look at this table. So this is the structure of employee. Yeah. Just in our previous diagram, but here we look at a little more information in the employee table. Yeah. So other than the first name, last name, social security number, you have a department number field, not null. All right. Yeah. Then let's look at the department table. In this department table, you have department name field, department number, manager social security number field, manager start date. Yeah. Then you declare primary key, D number primary key. Yeah. Then unique key. Yeah. Because you want to make the department name unique. Yeah. No duplicate values for the department names. Yeah. All right. So now the foreign key relationship. Yeah. All right. Dino points to D number in the department table. Then you define constraint, foreign key constraint. Because if you do not define it, the foreign key constraint, DBMS won't enforce that connection for you automatically. Okay, so you have to define that foreign key, we call the referential integrity constraint, explicitly in this way. All right, constraint, then give a name for it. AMP, department foreign key. So you know the meaning, the name. First table, EMP, second table, DTP, and the foreign key, FK. Yeah. Then foreign key declaration, parenthesis, Dino. Yeah. All right. Yeah. So depart that field. Yeah. Referencing field. Yeah. Then references department table parenthesis D number. Yeah, straightforward way. So you can see we just use straightforward way to define a foreign key like this one. Yeah. After that, then DBMS will enforce referential integrity constraint. Yeah. Okay. Yeah. So you can save a lot of work. You can imagine for large database, there are so many conditions there. So you like to make DBMS do automatic checking as much as it can to save programmers a lot of work, tedious, simple checking work in this way. All right. Note, yeah, create the tables in some right order. Yeah, because here we're talking about relationship between two tables, table 1, table 2. Table 1 references certain field in table 2, that kind of relation. Then table creation order is important. Table creation order is important. If you make some wrong order to create tables, you have trouble. Yeah. So look at this rule. All right. Yeah, you may have this rule trouble. Yeah. When you define a foreign key, the reference the table must be created before you define that foreign key. Yeah. Based on the logic, it makes sense, right? Yeah. Think about the logic here. If you want to reference certain key in another table, but that table does not exist because you haven't created. That could happen if you do not do the planning carefully in your database design. That could happen. Then you will have a DBMS complaint because the table you are referencing is not available. Okay, or table, yeah, to be referenced. Yeah, so yeah, you know, as the reference the table, it's not there. Yeah, yeah, so that's the simple rule. All right. Next, we will see we need to do things carefully, but based on this rule. Yeah. All right, so let me show you some more example. Yeah. D.3 foreign keys with circular reference. Yeah. You may have the circular references. A table that references itself. That kind of circular reference. A table, in a table, a field, yeah. So in that table, we need to create a foreign key. But that foreign key points to the primary key of the current table itself. That could happen. That could happen. Yeah. Here, let us take a look at that example. That example. Yeah. Foreign keys with circular references. Yeah. All right. Meaning of circular reference. Yeah. A table references itself. Is it allowed? Yes, because in the business world, we can find a situation we need to have this kind of reference. That could happen. Yeah. In our company database, we have that kind of situation. Yeah. So you will see a simple example. Yeah. The referencing table equals the reference the table. Yeah. Same table. Yeah. Then you may have some potential problem. All right. Yeah, but first, I'd like to show you that self-reference circular reference example to let you know it exists. Yeah. So let's look at that possibility. It is possible. Yeah. Let us look at this simple example. Yeah. All right. Still, table employee. Yeah. Company database table employee. Create table now. Look at these two fields. First, SSN, social security number. That is the primary key of this table. Employee, SSN, that's the primary key field. All right, after that, there is another special field. It is called super underscore SSN. That's the supervisor social security number. That's natural, right? Each employee should be assigned, should have some supervisor, right? Yeah. How to refer to that supervisor? You provide the social security number of that supervisor, right? Yeah. Look at that. Social security, supervisor. Is a supervisor a special employee in a company? Yes. Supervisor is also an employee, right? Yeah. So supervisor, that person also appears as an employee in this table. All right. So you can see this super underscore SSN refers to SSN of the same table. Is that circular reference? Referencing table equals referenced table. Same table. All right. Then our problem in the previous slide would happen. That is, when you define a constraint for this foreign key constraint, you need to create that table before you define that constraint. That's the rule. But here, how do you create that table? Because when you create that table, you need to define that constraint, right? But when you define that constraint, that table has not been created. Think about that kind of situation, right? Yeah. But we need to do that. In the business world, we have the need for this situation. So we cannot avoid this. So we have to implement this requirement in some special way. So here, let me show you the special way here. The rule, all right, yeah, still, when you define a foreign key, the reference the table must be created. Yeah, so that's the rule we already know. But the question is how to define a foreign key that refers to a table that has not been created, to be created. Okay? It's not there. All right. We can do that. Yeah. There is a special way we can do that. Yeah. We can create a table first without define foreign key constraint. After that, we have a chance to add a constraint after we have the table created. That's the alter table statement. Remember, alter table statement. We can use that to solve this problem. Yeah. Because alter statement, we always apply it after we create a table. Here you can see this feature is useful. Alter table, this feature is useful. It can solve our current problem easily. Yeah. So let us look at the solution. Yeah. Solution to circular references. All right. Solution steps, we do in this way to solve this problem. Yeah. Do not define the foreign key constraint within the referencing table. Yeah. In our employee table, we do not define foreign key constraint because later we have a chance to do it. Yeah. We just delay. All right. After the table has been created, use the alter table statement to define the foreign key constraint. Now, by the rule we mentioned in the previous slide, we follow that rule. Okay, no violation here. Yeah. Let us look at this example. After the employee table is created, yeah, then we write this alter table statement. Alter table employee. All right, yeah. Add foreign key. Out here, we do not give it a name. That's optional, right? Yeah. Add foreign key. Yeah. To which field? Super underscore SSN. Yeah. References, same table, still employee. Yeah, it exists. All right. Yeah. So you can reference employee table. Yeah. Parenthesis SSN. So after this alter table statement, we define that circular reference for foreign key. Yeah, yeah, that's the solution. Okay, all right. So that's this topic. Yeah. Next topic, violation for referential integrity constraints. Yeah. You may have some violation problem you need to fix. Yeah. So for this part, let us look at how to fix those violations. Yeah. All right. All right. When referential integrity constraint is violated. Yeah. So how do we solve the problem? Yeah. So could be violated, but we need to look at the cases. We may have some violation. Yeah. All right. Violation situations. Okay. First, when tuples are inserted or deleted. Yeah. When you delete a tuple, you need to provide values for certain fields. The values for those fields may cause some violation. Yeah. Okay. Yeah. Department number, you need to provide department number. The department number is a foreign key, you know, it points to primary key of another table. Think about the department number value you put there. If it does not exist in the reference table, what would happen? It's a violation. Okay, yeah. Deletion, you may have some violation problem. Think about, you know, deletion, you may cause some violation problem. All right, yeah. Look at our previous example, R1, T1, all right, R2, T2, look at that. And your T1 department D no field, right? D no field references D number field in T R2. All right. Think about if this tuple is deleted, what would happen? T2 tuple is deleted. Now, it has its primary key, but that whole department is deleted. What would happen? Think about that. Okay. Yeah. Because there are many other employee tuples, they refer to that deleted department. You have some violation because that department number won't be there in the department table. It's not there. The number you referenced in many places, not available. So that's another violation. So deletion may also call a violation. Yeah. Referential integrity constraint violation. When a foreign key or primary key attribute value is modified, yeah, modification can also cause violation. Yeah. So you change a value to places, foreign key place. After you change the value, the new value may not point to a valid department number. Then you have a violation, right? Yeah, you point to a wrong number. By accident, you enter a wrong department number. Okay, so that's the foreign key place. The primary key place, right? The primary key, all right. So if you change the primary key number, then all the tuples, they point to your old department number won't be available. Yeah. The old department number is gone. You change the department number to a new department number. Yeah. But there are many employees still reference the old department number. Then you have a violation. Referential integrity constraint violation. Yeah. Default action. Then we need to consider the action here. Yeah. The default action. Yeah. If you do not tell DBMS to do anything special, it takes this default action. You know, so what is the default action? Reject the update operation that will cause a violation. Yeah. So that's the default. Because you do not tell how to do it. You know, when DBMS detects this kind of violation, how to fix it? You haven't passed that information to DBMS. So DBMS does not know how to do it. Then it just takes this straightforward action. Yeah. Reject it. Yeah. So no change. Yeah. It's not allowed. Yeah. A violation detected. You cannot do this action. Yeah. All right. Optional actions. Then you can tell DBMS taking the following options when a referential integrity constraint violation is detected. Yeah. The first one, yeah, here, yeah, we call the referential triggered actions. Yeah. Triggered actions. All right. So you need, but we need to, someone needs to declare it, needs to, you know, tell DBMS to do it. Yeah. The first one, set null value. Yeah. The foreign key, for example, the primary key tuple is gone, then the foreign key, that field, you need to set null value, right? Yeah. So that's set null. Okay. Yeah. All right. The second, cascade. Cascade. Modification, you need to do the change in a cascade way. Yeah. So we will explain. So these options we will explain in the following slides. Yeah. Cascade option. All right. Set default option. Set default value. Yeah. If you know some appropriate default value could be set when there is a violation. Yeah. So that's the third option. All right. Yeah. The fourth option, restrict. That restrict, the last option, that is just the default option. Yeah. Default option, reject the update operation. That corresponds to restrict. Yeah. All right. Yeah. But if you want to declare restrict, you know, although it's default, yeah, you can use that restrict option for the default. Yeah. All right. Then let's look at you know, these two of the four options. I try to elaborate a little bit. The first one, set null. Yeah. So we want to look at the specific situation that we need to apply this option. Okay, yeah. All right. Let's look at this example. Yeah. All right. So our previous constraint we defined, yeah. Constraint amp depth FK foreign key deno references, department D number. Look at the, how do we specify our option at the end? On delete, see the action, on delete. When, so this trigger connects to the delete action, all right, on delete. When delete action happens, then DBMS, monitors if there is violation, referential integrity, constraint violation. If there is one, this set null option is triggered. Set null option is triggered, right? Triggered, what to do? That's simple. Set null, just set the foreign key field value, set that value null. Okay? That's simple. That's simple. Yeah. So you can see, let us use the diagram here. All right. Yeah. So, all right. And on delete. All right. So here, because the action is on delete. So delete what? Delete table to be referenced. Yeah. Deleted. T2 is deleted. All right. T2 is deleted. Then the foreign key in T1, that value won't be available in R2. In that case, you don't want to reject, right? Yeah. Because if you have some appropriate action to take, you don't want to reject. Yeah. If reject, you need someone to fix it manually, right? But here, if you have appropriate action to take by DBMS, you can do it automatically. Yeah. So here, what do? We set null. Yeah, we set that D null value null. That it's automatic. Okay. So after that deletion, although there is a violation, but there is an automatic fix in this way. Okay, yeah, pretty straightforward. Yeah. All right. Okay, and all other tuples, yeah, but here, after this change, it's not enough, right? Because the DBMS needs to fix the problem everywhere, not just one place. Everywhere in this table. Yeah. Because all other tuples in R1 whose D null values are equal to T2 dot D number. Yeah. So that's how we reference the value. T2 tuple dot its department number value. Yeah. Okay. Those values are also set to null automatically. So you can see, if that is what you like to do, then it's convenient. The DBMS does it for you automatically. Okay, all right. So that is the first example. Yeah. The second example. This time, referential triggered action, cascade action. Yeah, this name tells you the, basic things it can do in this way, cascade way. Yeah. All right, so let's look at the description here. Yeah. Example. All right. Here, social security number, yeah. Super, yeah. This place, that circular reference example, yeah. All right, yeah. AMP, yeah, constraint name, AMP super FK, yeah. Super underscore SSN, the foreign key. Supervisor's social security number references employee SS number. On update, yeah, look at that. On update, You may update social security number, right? Yeah, you may update. Yeah. Cascade. Look at that cascade. Okay. Yeah. So the many changes happen in that cascade way. Okay. Yeah. 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 Top, bottom, that cascade way. All right. Yeah. All right. All right. So let's look at this diagram. Yeah. This time, R1, R2, both equal to employee table. Yeah. Same table. Yeah. All right. T1 in R1, we look at that super underscore SSN field. Right. T2, yeah, we look at SSN field. Yeah. All right. Look at this action when it happens, updated on SSN. T2 is updated on SSN. Yeah. That T2 employee, for some reason, its SSN was wrong, entered wrong before. All right. Yeah. So later you find some, problem and fix it. When that happens, then let's look at a cascade change. Now, the cascade change. All right. Yeah. After that change, we know many other employees, they need to refer to this SSN number as their supervisor's SSN number. Yeah. So look at that. All right. So each, yeah, not just the T1, yeah, employees who have the similar situation as T1, yeah, that value as a super underscore SSN value has to be changed accordingly. All right. Yeah. And all other tuples in R1 whose super underscore SSN values are equal to T2.SSN also get changed. Yeah. So thinking this way. Yeah. All right. Yeah. All right. But you may think about, so you may have other tables also that could refer to this SSN field in employees table, right? Yeah. So you can make sure everywhere that refers to this field also get checked, updated. Yeah. Yeah. All right. So here you can see, so for in this class, so basically we can see, yeah, definitely first we cannot exhaust all the cases, right? We just look at some basic cases. Yeah. But the basic idea to let you know, you in your mind, you establish, a general picture. When you have the typical situations that could happen in the real world situations, the basic solutions look like this way. Yeah. So that's enough. Yeah. The details may not be that important, but in your mind, in your thinking, yeah, you can imagine your solutions, what your solutions should be. Yeah. Yeah. So here you can see, yeah. So basically we use this kind of solutions to solve problems, various problems, related to DBMS constraint violations, user-defined constraint violations. Yeah. All right, so that's what I like to cover in our part D, the last part of our module 3. Yeah. After that, we need to start SQL queries. So at this point, we do preparations for SQL queries. Yeah. So we need to have plenty of knowledge. But after that, we need to write SQL statement. Okay, based on the logic, based on what we understand. Yeah. So, and you need to build up some experience. Yeah. After you write some reasonable SQL statement, you need to do experiment. Yeah, in our SQL window, yeah, that place you copy paste, you can run it and see the result. Yeah. All right. So we will start to do SQL queries from our next class. Yeah. All right. So here, basically, yeah, because at this point, after we finish module 3, I need to give you quiz number 3. Yeah. At the same time, I need to give you our first homework assignment, number 1, covering first 3 modules. First 3 modules, 1 to 3. Yeah. And we need to work on our first programming project. So you can see this week, I will post 3 assignments, one after another, 1, 2, 3. Quiz 3, homework assignment number 1, and a project assignment number 1. Yeah. So 1, 2, 3. Yeah. All in this week. Yeah. All right. So that's it. So we've